So there are two different types of reasoning. There's inductive reasoning, which is using patterns or previous examples to form a conjecture, or deductive reasoning, which is what we're going to be doing in this example, which is using facts, definitions, and properties in a logical order to write a logical argument. That's also like proofs. My honors geometry will be doing proofs in this unit, but you guys are not going to encounter them until unit 3 and 4. But you will be seeing proofs in a little bit. Now I have, what do we call this little picture? It's a special name, a Venn diagram. So when we're working with logic, using a Venn diagram can actually be a good visual to help you understand what's going on. I chose something that's not math related to help you guys kind of adjust into this idea a little bit easier. Now everything that we're going to talk about here does not apply for a biconditional. We talked about biconditionals last unit. Last lesson. For a biconditional, doesn't the conditional statement need to be true? And doesn't the converse need to be true? Right? Doesn't that make the inverse also true if the converse is true? And then the contrapositive is also true? So if everything is true, right, in the situation of biconditional, none of this applies. Right? So this only applies in non-biconditional situations, which would mean the conditional is true where the converse is false. Right, so we're not talking about biconditionals here. This is just your run-of-the-mill normal situation. So the first law, which is the hardest to remember because the name is really, really weird, it's called the law of detachment. Okay, so law of detachment is when you guys start with P arrow Q. That's how all of your arguments always start. You have if this, then that. You always start with if P, then Q. The next line, see how I have 3 lines here, 1, 2, 3. The first line is P arrow Q, the next line is P, and then the last line is just, therefore, Q. So it's called the detachment because I took P and Q without the arrow and I split them, I detached them, and then they each got their own line. See how I did that? It was P and Q together, and I split them apart, and I have just P and then just Q. They have their own little line. That's why it's called the law of detachment. You detach P and Q and they get their own separate line. So this is actually going to be a valid argument. Let's take a look and see why. So if I say, if you are in this classroom, then you're in CVHS. That's true, right? Okay. Then I say, you are in this classroom, therefore what can I conclude based on the first sentence? If you're in this classroom, therefore what? Therefore, you are in CVHS. That's how the law of detachment works. So you begin with your if P then Q. If you're in this classroom, then you're in CVHS. Then you split the two ideas apart and they each get their own line. Now notice how these two don't have the if-then structure. Only the first sentence has if-then. And then they just give you the hypothesis and then they just give you the conclusion with the therefore in front. So there's no more if-then in here. They kind of just took the ideas and wrote them down separately. Right, so this is a valid argument. Right? Makes sense according to the first statement. And logically, if you're in this classroom, you have to be in the building. So makes sense, right? And it always will. As long as this first sentence is true, this reasoning, this argument structure will always be valid. All right, we also have the law of detachment contrapositive. Now remember last time we talked about logically equivalent statements. What two statements are logically equivalent? If you start with a conditional, what statement is logically equivalent to that? The contrapositive. The converse and inverse are logically equivalent, and the conditional and contrapositive are logically equivalent. That's why we learned that last lesson. So if you know that the conditional is true, doesn't that also make the contrapositive true? So we can use the exact same reasoning, but we can now use the contrapositive. So this is what your argument's going to look like. You're going to start with P arrow Q, like you always do, right? But then we're going to do the contrapositive. Instead of PQ, we're going to do not Q, not P. Remember that's the contrapositive when you switch and make negative? So instead of using PQ, they're going to use the contrapositive, not Q and then not P. It's the same idea. You're splitting the two and giving them their own line, but you're using the contrapositive instead of the original. So let's see how this one works. It says, if you are in this classroom, then you are in CVHS. True, right? Okay. You are not in CVHS. Therefore, you're not in this classroom. That's how the law of detachment with the contrapositive works. Right, so this is still called the law of detachment because I'm taking the two ideas and separating them like this, which is kind of what we do for all of them, but these specifically are called the law of detachment, but this one uses the contrapositive instead of the original structure with the conditional statement. Okay, so this would be a valid argument. right? It's called a law. Anything that's called a law is going to be valid. Anything that's called an error is going to be invalid. So we have 3 laws and 2 errors. All right, so we have the law of detachment, which is just P arrow Q, then PQ without changing anything. We have the law of detachment contrapositive, which changes it to the contrapositive. And then we have something called the law of syllogism. Syllogism. This one's really wonky. It's different than all the others. Have you guys ever seen those DirecTV commercials? Where they're like, if you have cable, then your TV won't work. If your TV won't work, then you'll stare out the window. If you stare out the window, then you'll see a murder. If you see a murder, then you have to fake your own death. Like that whole. Have you ever seen those commercials? That's syllogism. If you have a bunch of if-thens, well, then they keep stringing along if-then, 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 if-then. And at the very end, you link the beginning idea to the ending idea in your last statement. That's called a syllogism. So syllogisms can go as long and as long and as long as you want them to be, but for our situation here, we're just going to do 3 steps, right? So your first statement's always PQ. In all of these, you always start with P arrow Q, and then you're going to introduce a new idea called R. So we're going to go from P to Q, and then from Q to R, see the Q carries over, and then I introduce a new idea. And then to finish, you guys have to link the beginning and the end. So what was my first idea? P is where I start. Where do I end? R. So to finish your statement, you would link the beginning to the end. So P arrow R. So if we go through here, it says, if you are in this classroom, then you're in CVHS. If you're in CVHS, then you're in Clifton. Therefore, what's the final conclusion I can make? Almost. If you're in this classroom, then you're in Clifton. You link the very beginning to the very end. So my first idea was classroom, then I had CVHS twice, and then I had Clifton. So you basically link the 2 unique ideas, the beginning and the end, you link them together. Well, I was going to give you a mathematical example, but I can't think of one right now. This is basically the idea of subtracting something that's common. What do these 2 statements have in common? The CVHS idea. So if you erase the CVHS idea, like they're canceling each other out because you had them twice, then you're only left with the beginning and the end. That's how syllogism works. You just link the first idea to the last idea and you're good. And again, this is a law, so it's always going to be valid. Right? A syllogism is always going to be true. And I have this little note here with the asterisk. I know it's really small. But you could also use the contrapositive here. Because isn't the contrapositive logically equivalent to the conditional, like we were practicing so much last time? So instead of writing, if you're in this classroom, then you're in Clifton as a conclusion, what's another conclusion I could write that would be valid? Mm-hmm.
If you're not in this classroom, then you're not in Clifton.
That was the inverse.
If you're not in Clifton, then you're not in this classroom.
True. Yep. So you can write it this way, going from P to Q, or I'll let you guys write right here. I didn't write it in here, but I want you guys to throw the little therefore symbol, so dot, dot, dot.
That's better.
And then you do squiggle R, arrow, squiggle P, the contrapositive. So in addition to having P, arrow, R, you could also do dot, 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 squiggle R, arrow, squiggle P. Everybody write that too. Should have put it in here, but I didn't.
Read the test.
I'm sorry? Or project, whatever. You may see it in the future.
No,
Is there something?
here's the test. Are those like, are they going to be written the same way?
I will not give you the words and the symbols together. We're actually going to practice it on the next page. Whenever you guys are seeing this kind of writing, you're going to have just the words. You would have to insert the symbols yourself to understand it. Okay? Any questions?
Yeah, but you can the other thing.
Yes. So in addition to what we have right here, I need everybody to make sure you have this in your notes. In addition to this, you should write dot, 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 squiggle R, arrow, squiggle P, the contrapositive. That is also a valid way of ending a syllogism. Squiggle R, arrow, squiggle P. All right, those are our laws, right? Law of detachment with contrapositive, and law of syllogism. Those will always be true. Okay? Now we're going to look at our errors. These are invalid, right? So you're going to be able to write an argument. You can still write it, but it's going to be wrong. There's going to be an error. Your conclusion that you're going to write down is going to be false, right? So that's why it's called an error. You can still write it technically, it's just nonsense, right? It's just not true. So the way that the converse error works is you always start with PROQ. All of these start the same way, right? But then they're going to use the converse. What's the converse again? We learned that on day 1. What does say converse? It's Q then P. So what they do is they write PROQ, and then they split the two ideas, but what comes first? So they have the Q first and the P second. That's how you use the converse. So let's take a look. It says, if you are in this classroom, then you are in CBHS. True, right? Then we say, you are in CBHS. If you were going to continue with the converse, what would the next statement be? You're in this classroom, right? That's the conclusion, so write that down. Therefore, you're in this classroom. That's therefore P. But is that a true statement? If you're in CBHS, do you have to be in this classroom? No. So that's why this is an invalid argument. All right, what's a counterexample? If you think it's wrong, what's a counterexample? You're in CBHS, but you're not in this classroom. You could be in your history classroom or your English classroom, right? So that if you can think of a counterexample like we were practicing last time, that makes this false. All right, so that's why this is invalid. All right, the inverse error works the same way. You're going to start with PROQ, and then you're going to write the inverse. How do you create the inverse? The squiggles. You write the opposite, right? So you're going to start with PROQ. Your next line is going to be the opposite of P, and your last line is the opposite of Q. Remember, you don't have any more if-thens except for the syllogism. You're just going to take the two ideas, split them apart, and write them in their own separate lines. So the inverse error says, if you're in this classroom, then you're in CBHS. True. Then it says, you are not in this classroom. What would the following conclusion be if you use the inverse? Then you're not in CBHS. That would be the conclusion. So write that down. Is that true, though? If you're not in this classroom, does that mean that you're not in this building? No, what's a counterexample? You're not in this classroom, but you are in CBHS. You're, again, in your history classroom or in the cafeteria or something, right? So that makes this invalid. So anytime you guys try to use the converse or the inverse to make an argument, it will always be wrong. And again, remember, we're not talking about biconditionals. That's why it will always be false if you're using the converse or inverse. Okay? Any other argument you try to use, the regular conditional statement or the contrapositive will be true, because they're logically equivalent, but the converse and inverse will be false. Now, before we turn the page and practice a little bit more, I need to make sure this is very clear. You guys not only need to be able to recognize an argument, like I should be able to give you this in words and ask you what structure did I just use? You need to be able to read it and say, oh, that's the inverse error. Or read a different one and say, oh, that's the law of syllogism. You need to be able to recognize what logical structure I'm using, as well as finish it yourself. Okay? And that involves using symbols. My greatest recommendation for this is to write symbols out so you can recognize really easily. You guys know the converse is when Q comes first and P comes second. We learned that on day 1. So if you write it in symbols and see that happening, you can get it like that. It's easier to see in symbols than in words. So if you translate it to symbols, it's easier. Yes?
How are we going to know what's Q and what's Q?
You always start, like I've been saying. So first statement is always P or Q.
For the
Always.
example, the girl was going to give you Q's or first.
Yes. And the first statement they give you is always PQ. And then you build the rest of it from there. Okay? So let's turn the page and see what I'm talking about. We have a bunch of examples here. Right? I have all these arguments. Some of them are in words, some of them are already in symbols. The very first thing you're going to do is when you see something like this, is you're going to turn it into symbols. Because it's way easier to see what's happening when you're working with symbols instead of the words. Okay? So we're going to go step by step and convert it to symbols and then take a look. So, like I've been saying, your first statement is always what?
PQ.
PQ. So that's the first thing you're going to do. Your first statement is always PROQ. You always start that way. So if you skip practice, then you don't play. PROQ. The second line is you don't play. What is that? That's... nope. Compare.
Oh, okay.
It's Q. It's just Q. They didn't change anything. It started as negative, so if it stays negative, they didn't change anything. So it goes PROQ, then it states Q, and then what does it say at the end? Therefore P. Therefore P. Like this. Now that we've turned into symbols, what did they do? They started with P, arrow, Q, then they went QP. What is that? When they instead of PQ, they go QP. What do you call that? A converse. When they swap the order, it's a converse, right? Was the converse valid or invalid? Invalid. It's converse error. It's invalid because it's the converse error. That's the process you go through. Turn it into symbols. Figure out what's happening. Is it a converse? Is it an inverse? Is it a detachment? Stuff like that. And then you have to remember whether it's a law or error, and then you go from there. Okay? All right, next one. How do I always start? PQ. So this is going to be PQ. So you're going to start with that. 0, Q. So if you are tired, then you can't focus, which are then kind of hidden. And then the next statement says, if you can't focus, then you won't understand. R, yeah, when you create a new idea, we're just going to call it R. We have Q to R now. And then what's the last statement? Therefore, if you are tired, you won't understand. It's P to R. Or make sure you have the therefore symbol. Therefore, P arrow R.
There's no, like, then and on.
Well, sometimes the then isn't written. It's the same thing as like when you use the word that. Sometimes you don't write it. What do I call this? You guys remember the wonky one where they're all if-then statements? The law of syllogism, is that valid or invalid? It's valid because it's a law.
Law, I'm trying to spell it.
I know, it's a weird word. I don't know, Doc, if you can't spell it right. I had one kid last year that spelled it syllablotsum on a test. I don't know where she got that from.
Where's the P?
I don't know. All right. You guys see how it's easier when you have the symbols there? Instead of just trying to meddle with all the words kind of floating around. All right, next one says, if you're an athlete, then you're healthy. How does that start in terms of symbols? P, arrow, Q. Almost start. Oops, I left off the arrow there, sorry. P, arrow, Q. There's supposed to be an arrow there. All right, then it says, Blake is not an athlete. What's that?
R squared.
It's not a new idea. It's squiggle P. Just because I added a name doesn't mean that it's a different idea. I just made a specific. I made a specific example for the hypothesis. And then it finishes with, therefore Blake is not healthy. Yes.
Dots.
Uh-huh.
Squiggle. Q.
Yes. Therefore, squiggle Q.
That was so easy.
All right, so turning into symbols is the first battle. Now you got to figure out by looking at the symbols what law or error it is. If I started with PQ and then I went squiggle P, squiggle Q, what's that? That's an inverse. Now is that a law or an error? It's an error, so is this valid or invalid? Invalid by inverse error. Remember how I said on day 1 you need to be able to look at symbols and know instantly what kind of statement it is? That's why we were practicing that. Because when you see that, you need to know that's the inverse, which leads you to inverse error. Alright, this was already in symbols, so no need to change anything. I went from A to B, and then A, therefore B. That's law of attachment. When I don't change anything, nothing changed with the order, nothing changed with opposites or anything like that. All I did was separate the two ideas and stick them in their own separate line. That's called the law of attachment. That's the first one we learned. Is that valid or invalid? Valid by law of attachment. Again, when you don't change anything, you just write them in the same order, but they're separated in their own line. It's called the law of attachment. Oops. Come on, board. Don't fail me now. All right. What about this one? If Gabe takes the bus, then he will be late. I already knew the thing. Okay. All right. The first statement is always P, arrow, Q, so you're going to start that way.
I don't think an A.
Where? Is that I wrote on the board?
No, mine.
Oh, okay. Then it says Gabe won't be late. What is that in symbols?
Squiggle. Q.
Squiggle Q. The opposite of the second idea, which is squiggle Q. And then the third statement says, therefore, he did not take the bus. dot, 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 squiggle, dot, 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 squiggle, P. What do I call that? What do I call it when I start PQ and then I go squiggle Q, squiggle P? What's that structure? When you swap the order and negate, it's called the contrapositive. So do you guys remember what the law is called when we use the contrapositive? That it's called the law of detachment, and then underneath you would say contrapositive, and that is valid because it's a law. So it's the law of detachment, contrapositive.
Do I try to contrapositive?
Yes, you do, because it distinguishes the law of attachment from the other one.
Can we try it parentheses?
Yes, you can. You can also abbreviate if you would like, as long as I can tell what you're abbreviating. All right, any questions so far? All right, the next one is already in symbols again. So we have P, arrow, not Q, going to not P, and then therefore Q. What happened? Stuff happened.
Oh, how does that work? So, like, why
What
does
happened?
The squiggle line changed instead of Q to P.
Okay, so then what did I do? How did P start originally? It was just P, right? And then it switched to squiggle, okay? And then Q started as squiggle, Q, and then it ended as regular Q. No. Did I swap the order of them?
No.
What did I do?
Inverse.
It's the inverse. See how this was positive, then I wrote the opposite, and then this was opposite, and I wrote the positive? I wrote the opposite of them. Didn't change the order, just wrote the opposite, so what do I call that? It's invalid by the inverse error. Sometimes they'll do that to you. Sometimes they'll give you like extra little symbols in the first statement, and then you have to look to see what happened, what changed. In this situation, I wrote the opposites of the original, which is the inverse. Sometimes you don't always start with just your regular P, arrow, Q when they have symbols, so swap them around a little bit. All right. This one's a little bit weird, so pay close attention for this one. It says, if you're in school, then you're in CVHS. How would I represent that in symbols? Okay, you always start with P, arrow, Q. All right. Then I say, if you're in CVHS, then you're in Clifton. Okay, so we have Q to R, our new idea being R. And then our last statement says, therefore, if you are not in Clifton, then you are not in school. Okay?
And then squiggle P.
Yeah, therefore, squiggle R, arrow, squiggle P.
Isn't it just the opposite of the other one?
Well, I have 3 if-then statements, all right? And the last one is squiggle R, arrow, squiggle P. How does the law of syllogism usually end?
Dot, 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 P, arrow, R.
Yeah, it usually finishes with P, arrow, R. Does that mean that this is not the law of syllogism? Is this invalid because it didn't end with P, arrow, R? What do you call squiggle R, squiggle P if you started with PR? If it started as PR, but instead we wrote squiggle R, squiggle P, what do you call that? The contrapositive. Is the contrapositive also true if the original is true? Yes, they're logically equivalent. So this is still the law of syllogism, and it is still valid. We just call it the law of syllogism contrapositive. You can use a contrapositive as an alternative anywhere that you're using the conditional statement, because they are logically equivalent. So it's still a law of syllogism, but instead of ending with your traditional P, arrow, R, they just use the contrapositive instead, which is still valid. I bring this up because sometimes they'll do that to you, expecting you to think that because it doesn't end with P, arrow, R, it's invalid, but don't fall for their trap. It's still valid if they end with the contrapositive. If I had ended with, instead of squiggle R, squiggle P, if I ended with R, arrow, P, would that still be valid? If we usually start with PR, but I switch it to RP, Would that still be valid?
You are in school and you are in Clifton. No, sort of.
No, it says if you are in Clifton, then you are in school. Is that true? If you're in Clifton, you have to be in this building? No. That's called the converse. If you guys didn't have the squiggles, if you only swap the order, remember converse is not true for these situations. We're not talking about biconditional. So we assume that the converse is not true. So you have to have contrapositive. Anything else won't work. If you try to use the inverse or the converse, it's not going to work. Converse error, inverse error. So you can't do that for a solution. All right, what about our last one here? If there's no homework today, then I am happy. How would I represent that in symbols? Q. And then my second statement says, I am happy, which is Q. And my last statement says, therefore, there is no homework today, which would be,
What we
no, this is hypothetical. Dot, 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 P. So I started with PROQ, and then I swapped it to QP. What do I call that? Converse. Is that valid or invalid? It's invalid because it's converse error. Converse error. All right, so you guys do need to be able to recognize whether an argument is valid or invalid. Listen, the takeaway from this activity, you need to know if something's valid or invalid by checking to see if it's a law or error. And if you don't know what the laws and errors are or how to recognize them, you're going to be stuck. So that was the point of this activity. Does anybody have any questions?
When you count points off, we don't put the 3 dots from there for like a quiz.
If I ask you to write in symbols, I expect the dot, dot, dot to be there. If you're just using that in terms of like work off to the side for yourself, then no. But if I specifically ask for the symbols to be graded, then yes, I would.
Let's say something like you ask, like you get this was like a quiz with these like symbols, and then put that.
Mm-hmm. All right, another way that I could ask you questions about laws and errors would be asking you if you can or cannot write a valid conclusion. This one says, given the first 2 statements, can you write a valid conclusion? If so, you're going to write it for me. If not, you're going to explain why. In what situation would I not be able to write a valid conclusion? The errors. So if you notice that they're starting to write an error, can you write a valid conclusion? No. Whatever you write last would be false, like we've been seeing in the errors. In what situations would you be able to write a conclusion that's valid? The laws. So what you're doing in these situations, they're going to give you 2, right? You're going to turn the first 2 statements into symbols, figure out what law or error they're trying to write, and then finish it or not finish it, depending on what law or error it is. So for this one, how do you always start? PQ. So it says, if it's raining, I won't go outside, so you're going to write PROQ. Always turn it into symbols, guys. It's your lifeline here. So I start with PROQ. Then our next line says, it is raining, which is what? P. So you're going to write those down. Now, what does this look like? I know I only have 2 lines, but they're all unique. If I go from PROQ and then my next line is P, which law or error is that starting to write? The law of attachment. Remember, the law of attachment is where you have PROQ and then P comes first. What follows after? Q. So can I write a valid conclusion? Yes, because it's the law of attachment, which I abbreviated with LOD. Law of attachment. Now what would the conclusion actually be? Therefore, I won't go outside. Oh. Alright, so not only do you guys need to recognize the laws and errors from 3 lines, you need to be able to recognize it from 2, the first and the second, and be able to write down what the third statement is. Remember, the laws and errors are all unique, so if you just memorize what the setup is for all of them, you're going to be good with this. Alright, so if the dog is fluffy, then I like it. How would I write that in symbols? PROQ. First statement always starts that way. Then it says, if I like a dog, I will pet it. So that would be QR. What does this look like it's setting up to be? The law of syllogism. Alright, is that valid or invalid?
No.
It's valid, so I will be able to write a conclusion because it's a syllogism, it's a law. Now, I have 2 different lines here because there are 2 different ways that you can write the conclusion. Alright, what's our traditional way? PR. Our traditional way is to go from P to R. So what would my last statement look like? It would be therefore. Yeah, going from P to R would be therefore, if a dog is fluffy, then I will pet it. you have the first idea and the last idea linked together. That's your traditional law syllogism. So write that down. Henry, make sure you're writing, please. Alright. Now that's the traditional way. Now we talked about twice already that there is another way that you could write the conclusion. You can use the contrapositive instead. So instead of writing, therefore, if a dog is fluffy, I will pet it, you can use the contrapositive of that, which would be what? Nope, that's the inverse.
Yeah, I mean,
Therefore,
I mean, if I were a dog.
contrapositive.
My dog.
Therefore, if I will not pet a dog,
It's not fluffy.
therefore I will not pet a dog if it wasn't fluffy. If I don't pet a dog, then it wasn't fluffy. You take the two ideas. Remember, contrapositive is when you reverse and write the opposite. Contrapositive is when you take the original idea, swap the order, and write the opposite. Now, when you guys are writing a lot of syllogism for me, whether it's homework, quiz, or test in the future, or whatever, I don't need you to write both. Just pick one. I'm just having you guys practice both in this lesson so you could recognize that this is still a possible conclusion in case you see it in the future. Okay? So they've done that on the SLL where they don't give you a traditional syllogism, they give you the contrapositive one, and people are like, ooh, that doesn't look familiar. So I'm trying to make it look familiar for you guys. Okay? What about the next one? If I break my arm, a doctor will give me a cast. Symbols? Euro, Q. You always start that way. And then the next line says, Dr. Timms put a cast on my arm. What's that idea? That was Q, the second idea. All right, so what does it look like it's starting to do? It started with PQ, and then it started with Q. It looks like they're starting to write the converse. Is that valid or invalid? It's invalid, because it's the converse error. So would I be able to write a valid conclusion? No, so you just don't write it. If it's not valid, don't write it. Just leave it blank. Just write over to the side saying no, because it's the converse error, and that's good. So if it's invalid, you do not write a conclusion. You just explain to me what the problem is, and then move on. Okay? All right, this next one is a little bit different. All right, it says 50-year-old men buy sports cars.
Yep.
Is that a conditional statement? No, not the way that it's written right now.
Then how did you turn it into?
Exactly. We practiced this on day one. How do you turn something that's not a conditional into a conditional statement?
If you're 50 years old, you have to.
Yeah, you have to change it yourself. So you're on the right track. What is it?
If you're 50 years old and you buy sports cars.
Well,
Not 50 years old.
if a man is 50 years old, or if you're a 50-year-old man, then you or he will buy a sports car. You have to turn it into a conditional statement first so that you know what P and Q are. So if you see that it's not a conditional at the beginning, you better write it so that it is one. So I drew a little arrow and I wrote it underneath. If a man is 50 years old, then he will buy a sports car. It's the same idea as the original statement. Okay, so now you can turn that into PQ, all right? So when I say my dad is not 50 years old, that's the squiggle P idea, right? So I'm starting to write the inverse. Remember, the inverse is when you don't change the order, you just write the opposite of everything. So if I start with squiggle P, what would then follow? Squiggle Q. Now, is that a valid or invalid conclusion? It's invalid, right? Because it's the inverse here. So you would say, no, I can't. The original question said, can you write a valid conclusion? You say, no, I can't, because it was an error. So you leave that blank and you just say no, because it was the inverse error. Alright? These are the two different things you guys need to be able to do with flaws and errors. Be able to tell, guys listen, you need to be able to tell what law or error is being portrayed by using the symbols and understanding which law or error it is. And then this kind of situation where they give you two lines, you need to recognize which law or error it is from two lines, and then know if you can write a valid conclusion or not, and then actually follow through if you can. That's the application of this lesson. Is everybody okay with that? Does anybody have any questions? All right. I do have another exit ticket I want you guys to do, so listen up. This one is going to be for a grade. All right. It is all individual. right? They all have to be unique answers. It has to be completed by everyone. So if you have your phone, get it out. If you don't, I'll give you a paper prompt that you can use. Question 3 on here, it's going to have 4 questions. It's going to ask you for your name. It's going to ask you what class period you're in. It's going to give you question 3, which is a prompt that everybody's going to have to create a LAR error argument themselves that's unique to you. So don't try to copy off the next person. And then question 4 is going to be, is there anything you're still confused about? So I can see what's going on. So again, you can use the QR code or you can go on Blackboard. There's a link in the reflection tab. If you don't have a phone, I'll just have you do it on paper.